Welcome to this Cortex-M3 DesignStart video for getting started with the FPGA board. This video demonstrates how to load the Cortex-M3 DesignStart FPGA image to a board and then run it. By the end of this video, you'll be able to transfer your own designs to the FPGA board, and you'll have learned how to connect to the board with the ARM Keil MDK debugger. You'll also know how to start a debug session in Keil, which will be of use to you as you start prototyping and testing your own FPGA designs. To achieve this, we're going to perform 3 tasks. First, we'll turn on the board and connect it to a PC. Then, we'll transfer the DesignStart bitstream and software to the board. Note that the bitstream is an image of the RTL compiled to configure the FPGA fabric. We'll also take a look at the directory structure of the files on the board, so you'll know where to copy your own designs to later on. Finally, we'll test the connection to the board in the Keil MDK debug environment, and in there we'll look at the DesignStart FPGA self-test program that we transferred to the board in step 2. To use Cortex-M3 DesignStart Eval with an FPGA board, you'll need an ARM Versatile Express Cortex-M prototyping system FPGA board, which is also called the V2M MPS2 Plus board. Out of the box, DesignStart only supports this board, and this is what we'll be using in this video. You'll also need the Keil MDK5 debugger, also called Keil Microvision. This is available to download from this address here. ARM provides a free license for the tool, and instructions on accessing this license were included in the email that you received after downloading the DesignStart package, allowing you to run the full version of the Keil software. So first, let's take a look at the V2M MPS2 Plus board out of the box. It's supplied with a preloaded SD card containing the boot files for the motherboard, shown here in the SD card slot on the back of the board. We don't need to change this card for DesignStart prototyping. Instead, we'll upload new files to the card. The board has a UART to USB adapter that connects to the UART general purpose connector here. This outputs printf messages for you to view in a serial communication viewer. The board comes with a 12-volt power adapter for plugging into mains or line power, and there are a number of input and output sockets for connecting to a range of peripherals, including this mini USB socket. At the top left of the board is a 6-pin SPI connector. If you want to use the Mbed OS file system, you will need to connect the SPI to SD card adapter here. After you've installed the Keil debugging software, ensure that the SD card is inserted in the board and then power on the board by plugging in the 12-volt power adapter and pushing the on button. The default boot image loads and you will see the green LEDs flash, and the LCD display will display an image similar to this one. Connect the board to your PC using a USB cable from the mini USB socket located at the top of the board. Your PC may load some drivers and will show that a removable disk drive has been attached. Because this is a normal USB device, you can scan and fix it if the operating system ever reports that it is corrupted. The boot image that came with the board is not the one required for Cortex-M3 DesignStart. We need to locate the DesignStart boot image and an associated test program, and then copy these to the board. To do this, navigate to the root of the DesignStart package and go to Boards, Recovery. This directory contains the Cortex-M3 DesignStart boot image, the board configuration files, and the self-test program. Drag and drop the contents of this folder onto the device and agree to replace any files with the same names. If this is a new MPS2 board, you will have a copy of the original files supplied with the board so that you can still access them after this step. Now we want the board to boot and run the program that was copied over when we transferred the DesignStart image onto the board just now. To do this, reboot the board by pressing the on button twice to turn the board off and then on again. The configuration files we have just copied across instruct the board to load the Cortex-M3 boot image and run the self-test program. We can verify that the board has booted with the self-test program as the LCD screen will now show this display, which is different to the one that we saw earlier when the default program loaded. Let's take a look at the file structure of the files that we've just copied across and identify the ones of interest to us. First is the MB directory, containing the motherboard images. We are using the C directory, which is contained in this folder. The board file indicates which image is loaded, and here we can see that it is the Cortex-M3 DesignStart image, as it is the only one that is not commented out. This file also shows us that the AN511 application note is for DesignStart, and when we open the AN511 folder, we can see in the images text file the self-test AXF file that is running on the board. Later, when you want to add your own versions of the DesignStart system, you will need to reference them here in the images text file. If we look back to the top level of the directory, the software folder contains the program files, and here we can see the self-test AXF file that is referenced in the images text file. This AXF file is the program that the board will run when it boots. The config text file tells the board how to boot, but we can use the default settings defined in this file. Also of interest is the log text file, which contains a log of the boot process. Now we've loaded the self-test program to the board, we can observe its activity in the debugger. To do this, open Keil UVision 5 and select Project, then Open Project. Navigate to the DesignStart folder and the directory self-test, m3ds_self-test, build Keil, and open the self-test_mpb project file. If you see this warning, then you need to enter the license information for the debugger to run. To do this, select File, then License Management. This window shows only the evaluation license, which means that the debugger will run, but you will not be able to compile the test image. Now let's check that the debugger can identify the board that's connected. To do this, select the Options for Target button, then select the Debug tab. Here we want the CM/sys/DAP debugger selected, which works over the USB connection, and then select Settings. In this window we can see the device information, including the serial number and the device name. If the debugger cannot see the board, then these fields will be empty and there is a connection issue. For troubleshooting this step, visit the Keil website. Elsewhere in the Debug tab are options to configure what happens when the board is connected. There is the option to use a simulator instead of targeting the board, which may be of use to you when you test your own software. Now we have loaded the self-test program and the board is set up, click OK to close the window and select this button to start a new debug session. This changes the view and downloads the program code and disassembly for you to see here. In here we can see the code of the self-test program, and we can also see the registers here. This line, highlighted here in the disassembly code, is the reset vector at 31D8. You also have the option to step through and debug the code on the board using the step over button here. And you can see the register changes in the left-hand column here as you click the button to step through the instructions. It can be useful to see the activity in the memory view. To do this, we'll just show the values starting at address 0, which shows the values for first the address, then the initial stack pointer, and then the reset vector here, indicating a thumb state instruction at address 31D8 before the exception handlers. So at this stage we've shown how to transfer files to the board, which files are important when configuring the board and uploading your own designs, and how to connect the board to the Keil debugger and download and verify the code. Here are some tips to help you troubleshoot 3 of the common issues you may face when doing these tasks yourself. First, and as we've already seen, you must ensure that you have correctly licensed the ARM Keil MDK. You'll not be able to use the debugger to compile code unless you've done this. Second, if the connection to the board from the PC is lost while the debugger is running, such as the USB cable becoming disconnected from the PC, you'll see this warning. To resolve this, select Stop Debugging, then power cycle the board by pushing the On button twice, then select the Start Debug Session button to start a new session. And finally, if you're unable to verify the connection to the FPGA board in Keil, then the operating system may need to update its USB drivers. You'll know when there is no connection because when you select Options for Target, then select the Debug tab and the CMSIS DAP settings, it will report that there's no debug unit device found. To help the operating system update its drivers, close Keil and then disconnect then reconnect the USB cable from the board to your PC, and the operating system should update the driver automatically. Going forward, you can use the self-test program to test the connectivity and functionality of the board. This can give you a better understanding of how the different components of the board work. You can also begin to test your own designs on the board by transferring them and beginning to debug them in the same way that we have just demonstrated. For more information and guidance on using the FPGA board with DesignStart, see the DesignStart Quick Start Guide and the DesignStart FPGA User Guide. And finally, to share your experiences or ideas, or to access further technical information about designing on Cortex-M3, visit the DesignStart community.